Hello dear students of plus 2 medical, non-medical and respected teachers. So today I am going to discuss energy level diagram of hydrogen atom. So first of all, what do you mean by energy level diagram? So energy level diagram represents the total energy of the electron in different permitted or stationary orbits along with the various spectral lines emitted by the energy radiated or like when electron jumps from any higher energy state to lower energy state. So such a diagram is known as energy level diagram. To plot energy level diagram, first of all, let us discuss the total energy of electron in nth orbit of H atom. E is equal to minus 2 pi square m k square e raised to power 4 over n square h square. This is expression for total energy of orbital electron in nth orbit, or if you simplify it, it will be minus 13.6 upon n square electron volt. This is the energy of the electron in nth orbit for hydrogen atom, taking z is equal to 1. So for n is equal to 1, 2, 3 and so on. So we have E1 is equal to minus 13.6 upon 1 square, that is minus 13.6 electron volt. This is energy of orbital electron in the first state. They correspond to principal quantum number n is equal to 1. E2 is equal to minus 13.6 upon 2 square, that will be minus 3.4 electron volt. Similarly, E3 will be equal to minus 13.6 upon 3 square is equal to minus 1.51 electron volt. And E4 will be equal to minus 13.6 upon 4 square, because n is equal to 4 is equal to minus 0.85 electron volt. And E5 is equal to minus 13.6 upon 5 square is equal to 0.54 electron volt negative. And E6 and so on, E7 and so on. And when n is equal to infinity, E infinity will be 0. That is, energy of electron in the ground state or the first orbit is minus 13.6 electron volt, that is minimum possible energy. That's why this electron is bound to the nucleus, because energy is negative, and energy will be 0 only when n becomes infinite. So at n is equal to infinity, electron becomes free and it will go out of the boundness of nucleus. It becomes free. Now, to plot or to draw energy level diagram, so energy of various orbits is taken along x-axis, that is, it is represented by the horizontal lines taken with respect to some scale, specified scale. So energy taken along vertical axis in electron volts. So when n is equal to 1, this level correspond to ground energy state, energy is minus 13.6 electron volt. And when n is equal to 2, it will be minus 3.4 electron volt, then n is equal to 3, minus 1.51 electron volt. So we draw all these horizontal lines. And one thing is clear, as n increases, the gap between two consecutive levels of energy goes on decreasing, goes on decreasing, goes on decreasing, as it can also be seen on these from these values. So this difference is about 10.2 electron volt, and this difference is about only 1.5 electron volt, and so on. This difference goes on decreasing as n increases. So these are the energy levels, and at n is equal to infinity, it will be 0. So it means topmost energy levels when n is large, they are very close to each other, and at n is equal to infinity, they just coincide, and this is known as energy continuum, because at this stage at n is equal to infinity, electron becomes free. So now how to draw the various spectral series on this graph? So as we know that when n is equal to, when electron jumps from any higher orbit to n is equal to 1 orbit. So like this or this. This set of spectral lines is known as Lyman series. When electron jumps from any higher orbit to n is equal to 2, this is known as Balmer series. When electron jumps from any higher orbit to n is equal to 3, it is known as Paschen series. And when electron jumps from any higher orbit to n is equal to 4, it is known as bracket series. And when electron jumps from any higher orbit to n is equal to 5, it is known as Pfund series, and so on. These Lyman series are in the region of the ultraviolet region of wavelength, and Balmer series comes in the visible region, and Paschen series in infrared region, and they are also infrared region of wavelength. So from the knowledge of this energy level diagram or this formula, we can find wave number, wavelength, and frequency of various spectral lines. And one thing is very clear from this energy level diagram, that conjective energy levels, gap between two conjective energy levels goes on decreasing as n increases and becomes almost zero when n is equal to infinite. So electron becomes free. It means this is the lowest energy state of the, that is known as ground state. So it means if we are to take electron out of the gravitational pull, out of the nucleus field, out of atom, then we have to supply this much positive energy, minus 13.6. That is, we have to supply plus 13.6 electron volt energy when the electron is knocked out from the atom. And this plus 13.6 electron volt energy is known as ionization energy, or plus 13.6 volt is known as ionization potential. So ionization potential means amount of potential required to knock out of electron out of the atom, so that it becomes free. It goes to n is equal to infinity, and then it may go anywhere. It may emit any kind of type of energy, any frequency. Then that's why it's known as energy continuum. So, for example, how we can calculate wavelength, frequency, or wave number of these series? So you will be asked to calculate longest or shortest wavelength of Balmer series, Lyman series, Paschen series, bracket series. So you must know this Rydberg formula, nu bar 1 upon lambda r into 1 upon n1 square minus 1 upon n2 square. So when you have to find longest wavelength of any series, so n1 will be equal to 2, for example, for Balmer series. For Lyman series, n1 may be equal to 1, and so on. But if you have to find longest wavelength, then take n2 is equal to next to the first number, next to n1. That is for longest wavelength, Balmer series, n1 is equal to 2, n2 is equal to 3. And if you substitute these values, and substitute the value of r, which is 1.1 into 9.7, and you will get wavelength comes out to be 6563 angstrom. Similarly, for shortest wavelength, so when you have to find shortest wavelength of any spectral line, take n2 is equal to infinity and n1 according to the series. For shortest wavelength, take n to infinity and n1 is equal to 2 if it is Balmer series. Then wavelength comes out to be 3646 angstrom. We can see from these wavelengths which are the shortest and longest wavelengths. So other wavelengths will fall in between the two. So it means this Balmer series fall in the visible region of spectrum. So this is how we can calculate frequency, wavelength, or wave number, or energy from the knowledge of energy level diagram. This is the importance of energy level diagram. So all the best, be happy, good luck, stay tuned for next video. Sarbat da bala, say blessed.